travel business has seen a recent surge of interest, with several companies aiming to send tourists into space and even around the moon. So far, the companies in the lead are Jeff Bezos's Blue Origin, Richard Branson's Virgin Galactic, and of course Elon Musk's SpaceX. However, they still have a number of hurdles to jump in order to overcome limitations in technology and costs. Because of these, very few people have ever been into space thus far. A pertinent question here, of course, is where does space actually start? According to the Fédération Aeronautique Internationale, the governing body that controls definitions for spaceflight and air sports, space begins at 62 miles or 100 kilometers above average sea level. The USA and NASA have their own definition, that's only 50 miles above Earth. Even given this lower bar, only 562 people have ever been so high up, on a planet with a population of billions. And that's because space travel is extremely difficult and inefficient with our current technology. It also relies on fossil fuels, which are limited and heavy. The fuel on a shuttle can weigh 20 times more than the craft itself on a mission. In the future, however, cheaper and more efficient methods of travel will no doubt be available. Instead of using fossil fuels for energy, space shuttles of the future will have different thrusters. Ion engines, for example, are a technology that already exists outside the realm of science fiction. NASA has had one for years now called NASA's Evolutionary Xenon Thruster, or NEXT. This thruster works by utilizing xenon and solar energy to power its operation. Xenon gas is ionized by firing electrons through it, which is then propelled out through the thrusters. This process can be 10 times more efficient than standard shuttle thrusters and can reach very high speeds given enough time. That's the problem, however: time, as they are currently very slow at accelerating. If this problem is solved, ion thrusters could become commonplace. Another very real potential means of thrust is that of solar sails. Solar sails mimic a sailboat's functionality by using mirrors to capture the push from the sun's radiation, like cloth to wind. Icaros, a Japanese spacecraft, was the first ever to demonstrate this technology in 2010. Physicist Avi Loeb has speculated the interstellar object Oumuamua, which passed by in 2017, could have been alien solar sail technology, though this view is controversial. Perhaps, though, it is the preferred form of space travel. If we never learn to bypass the speed of light as a universal speed limit, much of the universe will remain out of reach. If we really need to travel to distant galaxies or solar systems, we'll have to do so in a generation ship. The idea behind a generation ship is that it's a self-sufficient craft that can last centuries while traveling through space. This option is likely a disaster option scenario where humanity is forced to flee Earth and search for another planet. Generation ships are stations and homes that will be all some people ever know. If a destination is over 100 years away, people will have been born and died on the ship without ever having stepped foot off of it. A ship like this would need its own water cycle, carbon cycle, and nitrogen cycle, as well as being big enough to house a population. In addition, it would need to block out harmful radiation and artificially create gravity due to the negative side effects that long-term weightlessness has on the human body. It would also have to be a completely sealed environment with its own food production and energy management. The closest anyone has come to experimenting with this is Biosphere 2. In 1991, 8 people sealed themselves in a completely self-contained system called Biosphere 2 for 2 years. They were overcome with a variety of challenges as they had to grow their own food, manage their own oxygen levels, and deal with the human factor of intense irritation at being around the same other people with no escape. They proved, however, that sealed ecosystems can survive for years, and this may be necessary for space travel one day. Then again, instead of traveling in a ship in the future, you might find yourself standing in line for an elevator. In 1895, Russian scientist Konstantin Tsiolkovsky came up with the idea for what he called a celestial castle, or a massive space station of sorts attached to Earth via a long tower. More modern interpretations call this a space elevator, and there are some serious thoughts about building one. If executed properly, the cable would be built of very durable and plentiful material and would transport people to and from the planet with an elevator. The trip could take mere hours and could be 100 times more cost-efficient to run than space shuttle launches. The space station at the top of this elevator could be a hub or a spaceport of sorts, with connecting flights leaving and entering. Launching shuttles from Earth is so expensive because they have to overcome the planet's gravity, but in space, that won't be as much of an issue. The idea is obviously difficult to execute, as the material it was built from would have to be so strong and so durable that it doesn't break from the forces and potential atmospheric debris impacting it. If it did break, the result could be catastrophic. Nevertheless, this idea might be a practical one. NASA itself has deemed the idea to be sound enough, and both China and Japan have said that they want to build one by 2045 and 2050, respectively. Someday in the future, you might be able to take a vacation to outer space by packing your bags onto an elevator and watching the Earth grow small between your feet to the soothing pitch of elevator music. Of course, we could also try to build spaceships that don't try to move through space fast, but rather manipulate the fabric of space-time itself. There are other proposed methods of space travel that could one day be real, but for now are merely hypothetical. Warp drives, for example, perhaps aren't as far-fetched as previously thought. The idea of a warp drive is to overcome imposed speed limits on space travel by warping space-time itself around the ship. One specific warp drive, thought up by theoretical physicist Miguel Alcubierre, is called the Alcubierre drive, and works by compressing space in front of the ship while expanding space behind it. And this is consistent with Einstein's equations, if something like negative mass is ever discovered or invented. NASA has even made modifications to the idea to make it more efficient, but it would take massive amounts of energy to run, and isn't anywhere near feasible yet. Similarly, wormholes could be future possibilities. They're also known as Einstein-Rosen bridges, and are tunnels that connect space-time in two areas by forming a shortcut through two black holes. This could potentially make a trip that would normally take 1,000,000 years traversable in only a few minutes. Our technology has a long way to go before we can even consider this a possibility, however. Just as humanity began exploring every inch of the ocean once boats were invented, it's likely only a matter of time before we move on to exploring the stars. Since spaceflight is a relatively new development, we still lack the technology and capability to make spaceflight cheap and efficient. With companies opening up space tourism and the potential to profit from it, however, more money is likely to go towards making this process as cost-efficient as possible. We may find ion thrusters and space elevators to be in the not-so-distant future. Or we could be surprised with a new form of space travel that we haven't even considered yet. And those are 4 ways you'll be able to travel through space